When calculating limits, it is useful to have a tool that will allow us to quickly make a table of values of a function. For example, let's take a look at the following limit. Limit as x approaches 3 of the function square root of 1 plus x minus 2 all divided by x minus 3. In this limit, x values approach 3. X values get closer and closer to 3. And to find this limit, we need to determine what value, if any, do the values of the function approach as x values approach 3. This limit can be found algebraically, but one way to approach the question is to simply make a table of values and look at the values of the function as x values approach 3 and see if they approach any specific value. Let's see how we can make a table of values of a function in an online calculator called Desmos. So you can go here to the website called desmos.com and then select a graphing calculator. Then enter your function. So here I entered f of x equals square root of 1 plus x minus 2 divided by x minus 3. By the way, if I try to calculate the value of the function at x equals to 3, f of 3, the calculator tells me right away that it is undefined, right? And that is because if we try to substitute x equals to 3 into this equation, the denominator becomes equal to 0, and we can't divide by 0. Okay, next, let's try to make a table of values. So I'm going to click on plus, and then select a table. I'm going to add a table to this worksheet. The table comes with 2 columns labeled as x1 and y1. I don't particularly need indices here, so I'm going to remove them. And then actually, because my second column is supposed to contain values of the function, I'm going to remove y and place instead of x, I'm going to type in f of x because I want the second column to contain values of the function. So now, every time I enter an x value in the first column, the calculator automatically will compute the corresponding value of the function. So for instance, if I enter x equals to 3.1, we see immediately that the value of the function for that x value equals 0.24, etc. Next, I can type in any other value of x that I want. So for instance, x equals 3.05, and voila, we have the value of the function for that value of x as well. And we can keep going like this, generating more and more values of the function. For example, here I'm going to choose x value to be 3.01, and I have the corresponding value of the function as well. Already this is very useful because you can quickly make a table of values in this way. And of course, this is much more efficient than using just a standard calculator and having to work with a specific x value every time you would have to plug it into the calculator and do lots of clicks before you can get to the value of the function. But with Desmos, you can even you can automate this process even further because you can actually create lists of values. So here, for example, I'm going to create first a list of values, which I will call n. I'm going to write n equals. To get a list, I need to use square brackets. And let's start with n equal to 1, and then we're going to go from 1 to, let's say, 10. Okay, how do I close this? Okay, I think maybe I'm missing another dot. Yeah, okay, so 1, 3 dots, 10. That means that n now is a list of integers from 1 to 10. And then I'm going to create another list, and this list will now be the values of x, although I'm going to call this list t. And this list will contain values that get closer and closer to 3. So I'm going to enter t equals 3 plus, let's put 2 raised to the power and here I'm going to enter negative n. Okay. So just to explain, I want to generate a list of numbers that are getting closer and closer to 3. Each number will be in this form, 3 plus 2 to the negative n. And the reason I take the exponent to be negative n is because when n ranges from 1 to 10, I want the additional term, which I add to 3, to get smaller and smaller. And so that's why I take that exponent to be negative. Now we generate another table, plus table. And here I'm going to label the first column with t. And notice that now it takes the list of those t values and populates that first column automatically with all those numbers. And as you can see here, these numbers get closer and closer to 3. Now, what I want my second column to contain, I want that column to contain values of the function f of x for these values of the variable. And so since my values in the first column are labeled with the letter t, I will now enter f of t for the second column. Okay, and look what happens. We now have a table of 10 values of our function populated automatically by the calculator, and I didn't have to manually enter each one of those 10 values. Now we can look at the values of the function and see that as x values get closer and closer to 3, the values of the function we can see here appear to be getting closer and closer to 0.24999, which if we round, that would give us 0.25. Now, we can even we can even go back and change our list for n values. So for instance, I can go and now go maybe not from 1 to 10, but go from 1 to, let's say, 20. And now when I scroll down to that table, now it's going to contain 20 values. And you can now definitely see that the values of the function approach 0.25 as the x values approach 3. And it's really very easy now to generate very large table of values, because I can now go and change n to be the list from, let's say, 1 to 50. And then scroll down, you can see that we now have a very large table of values. And then at some point the calculator begins to round. You can change the precision in Desmos to show more decimal places if you don't want this rounding to take place. But for our purposes, this is already good, because we can now definitely see that as x values approach 3, the y values approach 0.25. Going back to our limit, we can now say that the limit as x approaches 3 of square root of 1 plus x minus 2 over x minus 3 is equal to 0.25, which of course is 1/4.